Hello and welcome back to the debugging point. So in this video we are going to discuss about pointers and functions. So let's begin our discussion. We already know that we can pass different variables and arrays to a function, which you might have done already. Alright, you might have studied already about this. But can we pass a pointer to a function as an argument? Let's check it out. Say for example, you have a function somewhat written like this. You have an int I10, int star p is equals to ampersand I, and you have print p. You call the function print and pass pointer p to it. And what it does is simply prints star p. Alright, so let's try and run this. So this runs beautifully and successfully without any problem. Alright, hence passing a pointer to a function as an argument is absolutely legit step, and you can do it without any problem. Alright, so let's see to what extent can we actually exploit this. Alright, uh, let's say you have a function somewhat like this, increment pointer p. Let me paste it here. Yeah, increment pointer, which takes pointer p and increments its value to 1. Now what do you think will be actually be the output? If you have, let's say, let me do it like this here, what do you think will happen? All right, will there be a change, or will there be no change in the value of p before and after calling the function? Alright, we are doing nothing but just incrementing by 1 in the function. So first think intuitively and then check if you were correct or not. Alright, I hope you have given it a serious thought. It needs a lot of brainstorming. Alright, so let's see what will essentially happen here is we have the int main function, inside which we have a variable I. Let's say it has an address of 0x121. Alright, 0x is just symbolizing that it's a hexadecimal number. Alright, so it will have a 4 bytes of it will be a 4 byte long integer starting from address 1 to 1, in which the value 10 will be stored. Alright, then another second variable, which is int star variable, which is actually a pointer with the name of p, will be initialized. Let's say it has an address of 1 to 1, so it will have the address of I inside it. So we have stored the address of variable I inside it. I hope it is clear so far. Now, so on doing cout p, essentially the address of I will be printed. Alright, it might not be 1 to 1 when we compile, but yes, the address of I will be printed, which we know. Alright, now when we actually, after printing the value of p, when we actually call increment pointer function, then what happens is that inside the function another 8 bytes of memory is allocated for the pointer p, which is a separate entity altogether. What I mean is, a different 8 bytes of memory is allocated for the pointer p, which is defined here inside the function increment pointer. So a different 8 bytes of memory will be allocated. Let's say it is at some address 311, and this value will get copied into this value. Alright, so the p from int main, the value of p from int main function will actually get copied to the value of p, which is in void increment pointer function. I hope this is clear to you. So now since this is also a pointer and it has the address of I, so effectively this will also start pointing towards I. Alright, but this P and this P are two different entities. You might have already studied this from functions. So inside the function, when you do P plus plus or P plus equals to 1 or P is equal to P plus 1, then you are actually incrementing the pointer P inside the function. Alright, so this will actually get overwritten and it will become 125. So now this P will actually start pointing to this variable. Alright, this memory space. Alright, but as soon as the function is over and we return to the int main function, the value of P remains as it is. Alright, so on calling increment pointer P, here a new variable P is created for this very particular function, and the value of this P is copied onto this P which is inside the function. So if we perform any operation on this P, we have incremented this P, which means that only and only the variable in the function, its value has changed, and this value remains intact. Alright, hence when you see out it again after calling the function, the value remains unchanged. Let's verify. See, print P, so 10 was being printed. After that, the value of P before and after calling the function remains absolutely the same. This is only because the P, though the names are same, this is P and this is P, but this is a different P and this is a different P. This is the P which belongs to int main and this is the P which belongs to void increment pointer function. Alright, so essentially underneath they are actually under the hood, they are different entities. Alright, so another brainstorming question for you, but with a very same concept. If you have defined a function like this, let's say increment, let me copy it for you here. If you have a function increment like this and you call increment rather than increment pointer, now what this increment actually does, it takes the pointer and it dereferences it and increments the dereferenced value. So let's see what happens. See, we have a pointer P which is pointing to I in the int main. When void increment function is called and P is passed to it, then a copy of P from the main function is made, and the variable P from the increment pointer takes the copied value from the main function. Alright, this we have already studied a few minutes ago. So effectively both the P's, the variable the pointer P from int main and the pointer P from void increment, both will start pointing towards this memory address which is I with address 121, because both of them have the address to this memory location. Alright, now in this function you are dereferencing the value, you are dereferencing what was kept inside this, which means you are actually accessing this memory, and on this memory you are actually performing plus plus operation. Thus, the value will get overwritten to 11. So even when the function is over and we return back to the int main function and we try to see out the value of I, then the changes will actually be reflected. We can verify this. Let's just verify this. See, star p, we need to check the value of star p because p will remain intact. Alright, we actually need to check the value of C. First print P, then the value of star P. The value of star P will be 10, and after calling the function it becomes 11 because we are dereferring the value to which the pointer P was pointing. Alright. The pointer P here, both the P's from the int main as well as from the word increment were pointing to this very particular memory. Alright, this particular memory. So, on dereferencing inside the word increment function, if you dereference and perform any arithmetic operation on it, then this memory will actually get overwritten and you will actually see the changes even inside int main function. Alright. I hope this concept was okay to you, and I hope now it is clear. So now we move on to a newer concept which is known as passing arrays to function. Alright. So there's a possibility that you might have already studied this topic inside functions, but I wanted to show you some very beautiful stuff which is happening around in here. Let's see in this piece of code. Let me show it to you. See, in this piece of code you have an array A10 which has 10 elements. Alright, so when you do the size of A, let me just comment it for you. When you do size of A, you actually get the answer 40. Why is it happening? Because integer takes 4 bytes of memory, and since there are 10 such blocks of memory in an array, thus a 40 byte memory has been allocated to A. Alright, we know that integer array's name, that is A in this case, will behave very much similar to pointers, but it is not exactly pointer. We already know that. When we call a function and we pass the argument as an array to it, then array is actually not passed to the array. Array is not actually passed to the function. What I mean is, see, even if you try to run this function, this function will run absolutely fine. You are passing this array to the function, it is accepting this, it is performing some operation. Alright, and if you want, you can see out the sum as well. Alright, let me run this once more. See, but in reality, actually, when you are passing an array to a function, it is not passed in the form of array. It is rather passed in the form of an integer, in the form of an pointer. I can show it to you. See, if you do size of A in this case, in case of sum, then actually the answer that you'll get is 4. In your systems, see, the first value that is printed is size of A, which is 40. Alright, we know why is it coming. Then you call sum of A, you go to this function, the compiler processes the code, it sees cout size of A, so it outputs 4. In your case, most probably it would be 8. This is because the size of pointer in my compiler is 4 bytes, and in your compiler it would be most probably 8 bytes. So how is it happening and why is it happening? See, arrays are huge in size. You see, they are so big in size. So they creating a different copy altogether for a function can become very expensive. So on passing array as an argument of a function, what compiler does is that it knows that arrays are very closely related with pointers. So it takes a pointer. See, if you have an array A like this and you call it in a function, then it actually creates a pointer for it, and the address of the pointer is that of the array. So this actually creates a pointer which is pointing towards the 0th element of the array. Alright, so when you do size of A, this is actually gives you the size of a pointer. You can even do it like this. Instead of the square brackets, you can simply put int star. It will also run perfectly fine. Alright, you can see the results. The outputs are exactly the same. Alright, so an array entirely is never passed. Array rather can never be passed because creating another copy of array is altogether a very tough and a very time consuming task. So what compiler does is it creates an pointer instead of creating the entire array again, and that pointer has the address of the starting or the 0th element of the array. Alright, it has the 0th address of 0th element of the array, and we know that these kinds of expressions are interpreted by the compiler, or I should say are processed by the compiler in the form of star a plus I. So irrespective of the fact that it is actually an array or a pointer, a is actually an array or a pointer, this information will get processed in the very similar way. So this was a very fun fact, and even if you write it this way, then also compiler knows that it's an array. So let's not make it an array, let's make it a pointer type, because creating and duplicating an array completely is a very tedious task in itself. So I hope this was a video which was understandable by you. A small information that I would like to give to you. See, it is not always necessary that you pass the entire array to a function, since we know that a function accepts array in the form of a pointer. So, see line number 20. It has passed a plus 3 rather than a. You see, a is the array we know, and it has the starting address or the address of index 00 index element. Alright. So when you do a plus 3, it is actually the address of the third element of index number 3 element. Alright. So on line number 19 by A, we are actually passing the address of 0th element. By A plus 3, we are actually moving A, we are actually passing the address of 3 elements ahead, which means index number 3. So in this case, we are we are passing the address of index 3 element. In a way, thus, we have sent only elements from index number 3 onwards, which means that we have sliced our array, or we have sent only a particular portion of our array to the given function. Alright, I hope this piece of information was useful to you. Thank you.